So here we are, section 3.4. 3.4 just takes all of those tools that we've looked at in chapter 3 and has you use those as tools to solve problems. And you're going to have to look at a word problem, figure out what the triangle looks like, then decide whether or not you have a right angle triangle and can use SOHCAHTOA or Pythagorean theorem, or if you have either of the instances or situations in which you can use sine law or cosine law. All of that information which I've listed right there at the top of the page. We've got SOHCAHTOA for right angle triangles. We have Pythagorean theorem for right angle triangles. We have the 180-degree rule, can be used for anything. We've got the sine law and we've got the cosine law. Remembering though that the cosine law will only work if you have a triangle with all three sides or a triangle with two sides and the angle between them. Okay. So let's look at example 1. 2 security cameras at a museum must be adjusted to monitor a new display of fossils. The cameras are mounted 6 meters above the floor, directly across from each other on opposite walls. The walls are 12 meters apart. The fossils are displayed in cases made of wood and glass. The top of the display is 1.5 meters above the floor. The distance from the camera on the left to the center of the top of the display is 4.8 meters. Both cameras must aim at the center of the top of the display. Determine the angles of depression to the nearest degree for each camera. So we are looking for is, well, theta here and alpha over here. Now this question's given you the nice triangle diagrams, so it should be pretty easy to see. Well, right here I have this is a right angle triangle, so I want to use SOHCAHTOA. I'm going to quickly redraw that down here just so that I have something to work with. There's my right angle triangle, close to a right angle triangle, and I know that this is 4.8, and I know that this is alpha is what I'm looking for, and this is 4.5. It's an ugly 4.5. 4.5. And we have to find this angle theta. Well, I know that this side here is my hypotenuse. It's opposite to my right angle triangle, or right angle in my triangle. This side is opposite the angle that I'm looking for. What trig function relates opposite and hypotenuse? Well, that's going to be, if I had SOHCAHTOA up here, CAH. What trig function relates opposite and hypotenuse? Well, that's going to be sine. Write down my formula. Sine of an angle is equal to opposite over hypotenuse. Substitute in values that I have. Sine of theta is equal to 4.5 over 4.8. And of course, now remembering that in order to calculate an angle, I have to use the inverse function of sine. So my angle is going to be sine minus 1 of 4.5 divided by 4.8, which works out to 69.635865. Or if as a final answer I could say 71 degrees. And that would be alpha. I go back to my picture, take out these squiggly lines that I drew. Now I know I'm looking for angle, sorry, not alpha, I said alpha, I meant theta. Now I'm looking for angle alpha, which I'll do in purple over here. See that it's part of this angle system here. 1, 2, 3, this being 12, this side being 4.8. Well, I know this angle too, I just calculated it. So let's redraw a new triangle. 1, that didn't work. 2, 3. This is 4.5. This is 12. Alpha is what I'm looking for. And I know that this angle is not 71 but 60. Oh, I said 71, it should be 60. It should be 70. 69.635865. And then let's just back up because I realized that I rounded down here to 71 and it actually should be 70. So hopefully you guys are all screaming and wondering why I did that and are writing notes saying, I gotta check with Mr. Tomiyama in the morning. Anyways, there we go, 70 degrees. bad math, bad rounding skills there. Anyways, this is where we're at. We have to figure out what alpha is. Well, how do we do that? We know we have right angle trigonometry, which we can toss out the window. We do not have a right angle triangle. We haven't been told that, so we're not even going to use it. We could use sine law, which is going to allow us to possibly calculate these angles. This angle side relationship, this angle side relationship, this angle side relationship, but I'm missing an angle here. I'm missing a side here, and I'm calculating this angle here. So sine law is not going to work. So the first thing I actually have to do is use cosine law with this angle to find this missing side. Once I have that missing side, well, now I can use sine law to calculate for alpha. So a two-step question here. So let's start with calculating that side. So I'm going to relabel my triangle. This is going to be angle A. This will be side A. And we're looking for a side, so it's going to look kind of like, this. X squared is equal to, no, let's start with the formula. A squared is equal to B. Don't know what's going on here. There we go. A squared is equal to B squared plus C squared minus 2BC cosine A, which is going to be 12 squared plus 4.5 squared. Nope, not 4.5, 4.8. 4.8 squared. This should be an 8. Again, might have to redo this video later. 4.8 squared minus 2 times 12 times 4.8 times the cosine of 69.635865. And yes, I have to use all those digits because I don't want to use a rounded value in my questions. Punch that into your handy dandy calculator. You get, I'm going to move this A. You get A squared equal to, I had a 126.9520962. Of course, last step here, looking for a side, I take the square root. Both sides gives me A is equal to 11.26730.208. That's side A. Now, once I have that side A, I can use sine law, calculate back and forth. I could, if I wanted to, redraw the other part of my triangle back onto here and use SOHCAHTOA, right angle trig, because we knew this was going to be that 4.5. Don't have to do it that way. In this case, I'm actually probably not going to because the comfort level with sine law is pretty good. So now I have this. So I'm going to write down my sine law. Sine A over A is equal to sine B over B is equal to sine C over C. Now I actually have to label A and B. Let's call this B then, just for simplicity. So I'm going to go sine A, which is 69.635865 over side A, which I just calculated to be 11.26730.208 is equal to sine fishy or alpha over side B, which was going to be 4.8. From here, cross multiply, divide. That's going to give me sine alpha equal to 4.8 times the sine of 69.635865 divided by 11.267302088 into your handy dandy calculator. Sine alpha is equal to oh, you know what, I don't have that decimal number punched out or written out, but I know because I'm looking for an angle, I'm going to go sine minus 1 of that number, whatever that happened to be. I don't have my calculator, bummer. And my angle measurement is going to work out to 23.539784 or 24 degrees. So we knew this is 24. This over here, 69. So fill these in though, punch in your numbers, punch in the calculator, fill those numbers in so you have them written there. Otherwise, there's example 1, using all the different tools at our disposal.